1 minus x. This one doesn't need anything, but this is 1 over 1. So what do I need to multiply its numerator by?
One minus x.
Perfect. So then I have 1 plus 1 distributed here. 1 plus 1 minus x. Great job. Of course, I'll combine like terms. I know that x minus 1 is over, x minus 2 is over 1. And when I simplify this, I copy it and I flip this one. So the top is 2 minus x over 1 minus x times 1 over x minus 2. And you know me, now I have my circle. So this circle continues here. Of course, I cannot simplify these two. They're not the same. But I can factor out -1. And please tell me what we get when we factor out -1 there. What do we have left in parentheses?
So minus 2 plus x.
So we had minus x plus 2. So now what do I have here?
Is it x minus 2?
Good. So let's check. -1 times x, negative x. -1 times -2, positive 2. Now I can simplify. What is the final answer of this simplification?
-1 over 1 minus x.
Right. And if I factor out -1 in the denominator, I will have 1 over x minus 1. Excellent. So we determined that the slope of PQ, now I'm copying the beginning, and I'm copying the end. Oh. And now again, can you plug in 2 in here and tell me the slope?
Is it undefined?
Let's try again. Can you plug in 2 now in this expression? Maybe the confusion is that by mistake I wrote.
Would it just be 1? 1.
What was our guess?
1.
Awesome. Any questions? So what have we done here? What have we learned here? We have learned that, what we learned last time already, that if we have a point and we start with secant lines, and if we bring Q closer and closer, closer and closer to P, from one side or the other, or both at the same time, it doesn't matter, we really change this secant line into the tangent line by simply bringing Q closer and closer. That's what we did. We started at 1.5 and we got to 2. We started at 2.5 and we got to 2. Any questions? I'm going to share my screen. So now you know how to determine the slope of a tangent line, although you only have 1 point. So this is an identical situation. It's just a different function. So if I assign this for homework, you will know what to do, correct? Now let's look for a second at something like that says the deck of a river so is such and such. We have the function, of course. Find the average velocity, or the average rate of change, in other words. Velocity, It's the same thing. We're talking about the rate of change of distance with respect to time. So it's like any function that we just looked at. And find the instantaneous velocity. So let me just put it in writing. Average rate of change is the same with average velocity. If the function is the distance. Here we had some function, but if this is the distance, all these numbers will be average velocities. Now, again, what did we say was the slope of the tangent line? What is it equal to? Well, we didn't write it, so let's write it now. So the instantaneous rate of change or velocity if the function, oops, I heard it. So the instantaneous rate of change or the instantaneous velocity if the function is distance are the same with, I heard that, not sure why it does that. I have no idea. Let me change the hub again. Okay, I hope it's okay now. The instantaneous rate of change or velocity, instantaneous velocity. So these, or I should say, is the same or are the same with the tangent, the slope, I'm sorry, slope of the tangent line. They are the same. The average rate of change is the same with the average velocity and the same with the slope of the secant line. Let me also write that. And slope of secant line. Let me read this just to make it sure. Clear that it's clear. The average rate of change is the same with the average velocity and the slope of the secant line. All the same. The instantaneous rate of change or instantaneous velocity, they are the same with the slope of the tangent line. At that point, of course. So I want to talk a little bit and then we can move on. Okay, where is my share? Okay, so I want to talk about something like this, either 5 or 6. It says if a rock is thrown upward on the planet Mars, it doesn't matter, with a velocity of such and such. We have the function. Find the average velocity over the given time intervals. What would that mean? F of 2 minus f of 1 over 2 minus 1. F of 1.5 minus 1 over 1.5 minus 1. F of 1.1 minus 1 over 1.1 minus 1, right? Is that okay? And then estimate the instantaneous velocity. Do we understand the concept? Please let me know, yes or no. Do you think we should work on another problem?
I'd like one more problem if that's okay.
Yep, they are all the same. They're all the same. So do you want to work on something like this, saying, okay, so let's do 5. So on 5 we have, we're given the function, so f of t equals 275 minus 16t squared. Find the average velocity of the pebble for the time period beginning with t equals 4. So t equals 4 and lasting 0.1 seconds or 0.05 or 0.01. Very good. Okay. Again, we will start with our picture so we know we don't make an error. Here's our point. So this is our point P. And what are the coordinates of P? And this is our point Q. And what are the coordinates of Q? Forget about these for a moment. Can anyone give us the coordinates of P? That's the starting point. I need to identify P and Q. Once I identify P and Q, this is a piece of cake. This will be a piece of cake. Can anyone give us the coordinates of P? Anyone? If I don't get an answer, it means that I wasn't clear in my explanation. I always blame myself.
Is it 4 for the x?
Absolutely. Good. How do I determine this?
19.
So you plugged it in? Very good. F of 4. 275. I didn't calculate anything. We just picked 16. So how much? Was it 19?
I got 19, yeah.
Okay, I trust you. Good. Can anyone give us the coordinates of Q? So this is basically the third problem with identical setup. Maybe I should just show the previous one.
Is it t and then 275 minus 16t squared?
Thank you very much. Awesome. So we have, excellent. Thank you. Was that Victoria? No, Caitlin? Thank you. Thank you both, no matter what. Whoever answered, I'm happy. Good. So then now you're going to give me MPQ. What is MPQ?
Is it 275 minus 16t squared minus 19?
Awesome.
T minus 4.
That's it. Great job. That's what it is. So now all we have to do is worry about those numbers. So we start with T. We will have the slope, MPQ. So now we have to identify T. In the previous example, they gave us T or X. But here they are trying to trick us. They said the interval starts at 4 and lasts for 0.1 second. Starts at 4 and lasts for 0.04 seconds. Starts at 4 and lasts for 0.01 seconds. So, what is my T then? If this is 4, what is this? So that the period or the time elapsed is 0.1.
Is it 4.01?
Very good. So since we have to put them in correct order, I prefer correct order. I'll start here with 4. Leave it alone. 4. What will be the next one correct in line? Closer. And then further away, further away, further away. Higher, 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 higher. What will be the first one? Keeping in mind that we have 0.01, 0.05, 05, and 0.1.
0.01.
Yes. What will be the next one?
0.1.
0.05. And then 4.1. Excellent. Exactly like before, we can simplify this tiny bit. Negative 16 squared. And then plus, how much is this? Is it 256? Correct me if I'm wrong. And t minus 4. And leave it alone for now. We're going to come back to it, of course. Okay? So for now, we're going to plug this in. Remember, with parentheses, absolutely. Parentheses around numerator, parentheses around the denominator. We're going to put in these numbers and then guess. And then simplify. And there is no guess anymore. Okay, in y equals, I'm not going to record this. We recorded 1. I think it would be enough. So parentheses, negative 16 x squared, and then plus 256, close, divide by, x minus 4. We then have t, of course. And then I plug in those 3 numbers. I want to plug in 4. I itch to plug in 4. What will happen? Anyone? You are muted in case you are speaking.
25.
Of course, of course. So now I only have 4.01. I have 4.05. And I have 4.1. Yay! Done. So I'm copying. For now, I'm just going to copy negative 128.2, negative 128.8, and negative 129.6. Okay. Good. So what is your guess? What would be your guess? If you
128.
if you want to, yes, if you want to have the best, you're going to write 4.00000000001 because you cannot plug in 1. I mean 4. So I really hope that this is negative 128. That's my guess. But I have my little triangle, and I want to see what I can come up with. Of course, I will factor out negative 1. I don't like anything, any expression that